This image of a model is AI generated, and it's not just by using any of the subscription services, but completely free of cost by running a Colab notebook. You can also run the same notebook on your machine if you've just got a basic 8 gig GPU on your desktop. So without further ado, let's get started and find out how we can go about generating an image like this. So to get started, as a step 0, we have to make sure that we have a GPU machine at our disposal. If you have a Gmail account, you will obviously be able to run Colab, which means that you will be having a T4 GPU available free of cost. In order to enable the T4 GPU, all that we have to do is go under Edit, Notebook Settings, and we have to choose T4 GPU. If you're lucky, you should also be able to choose any other GPUs that are more powerful, but T4 GPU will do the job for us this time. Once we have made sure that a GPU is available, the first step is to ensure that all the Python packages that are needed for the execution of our script. We'll need the transformers library, and we'll need the accelerate library, and we'll also need the bits and bytes because we are going to be using quantized model. And we'll also make sure that we'll use HuggingFace because we are going to be pulling one of the 4-bit quantized models from HuggingFace Hub. The next step is to log into the HuggingFace ecosystem. For that, we'll have to head to the HuggingFace site. We'll have to log into it. On the top right, if we go to access tokens, we should be able to see the tokens belonging to us. We should be able to create a new token. And once you click on create a new token, we'll have to give a name and the value will be generated. So we'll have to copy that value and then paste it under the secrets. In the Colab, we can see that there's a key here. So if we click on that, we can add whatever the secret tokens or secret variables that we like to keep. That's the HuggingFace token, HF token that I have created, and I've pasted the value here. So to access this HF token from the Google Colabs, import the user data, and then we'll have to get the HF token, and we have the HuggingFace token. With that token, we'll have to invoke the login function from HuggingFace Hub and pass the HF token, and we'll be logged in to the HuggingFace ecosystem. Now, why are we doing all this? We are going to be pulling the model that we'll be using from the HuggingFace Hub so that we can run inference on that model. And this model is obviously going to be a 4-bit quantized model, as we will see in the upcoming steps. The next step is to define a small function in order to clean up the GPU memory. This is because we are working with a huge model that is just memory starved, and we need to make sure we manage the memory manually so that we don't waste much of the resources that are available. All that we are saying is that we would like to empty the cache, and we would like to reset the maximum memory allocated to the GPU whenever we want by just invoking this clean GPU function. Step 4 is to encode the prompt that we'll be passing to the model using the T5 encoder. For that, we are going to be importing the T5 encoder model from transformers library, and then we are going to be pulling the 4-bit quantized Flux model. When I was looking in HuggingFace Hub for 4-bit quantized version of Flux 1 dev, I found out this one, and I'm just going to be pulling that model and I'm going to be using that. So I've defined it here and I'm just passing it, and I've got the text encoder defined. Once we have the text encoder, we are going to be creating a Flux pipeline with the Flux Transformer 2D model. For that, again, we are going to be creating a pipeline using the Flux pipeline. Because we would like to also use the CPU memory on top of the GPU memory, we are going to be enabling the model CPU offloading. So we'll be offloading some of the workload to the CPU from the GPU, and there's a lot of flexibility going on once we enable that. Once we have that, we need to define the prompt, and the prompt that I have defined is a cute model on London Bridge photo shoot. It's such a small prompt, but does the trick for us. So what we are going to do is, using the pipeline that we have defined to encode the prompt, we are going to be passing the prompt, and then we are going to be get the embeddings of the prompt. Then we'll have to clean up the GPU because we need the GPU for the generation of the image now. All we have to do is we'll have to pass the pipeline to the CPU, and then we will delete the pipeline because we no longer need the pipeline because we already have the prompt embedded. And so we are free to now clean up the GPU. Once we have the GPU free, next we can move on to the step 5, which is the image generation pipeline. For the image generation, we will be using the Flux Transformer 2D model, and we'll be using the checkpoint that we just defined, which is this checkpoint, and we will be passing that checkpoint, and then we'll be creating the 4-bit transformer model. And to the transformer model, we will be passing the checkpoint. One thing to note here is that we won't be passing the text encoder and the tokenizer because that's not needed here because we have already done that previously. We already have the prompt embedded, so we won't be passing that. All that we'll be passing is the 4-bit transformer model, and we will be pushing it to the GPU because we want to run the inference on the GPU. And the last and the final step is to generate the image. For that, we first have to define the size of the image that we would like to be generated at. The smaller the size, the lesser the utilization of the GPU. So I've gone for a medium size image, which is like 512 by 512 rather than a HD 4K image. And then we'll be passing the embedded prompts as input. So this is one of the parameters. The more the inference steps, the better the image quality that we will get. But I've just stuck with 20. Maybe we can give a 30 or 50. This will only lead to a better image quality. We'll also have to pass the height and width of the image that we just defined. So once we pass all of these parameters along with the prompt, the pipeline will give us the generated image. We'll just look at the first image that's generated, and that's the image sample. We'll save it as result, and we can see the result of the generated image. We can probably run it one more time and then find out how the image differs from this image that we have just generated. I already showed you one image in the beginning, and that is quite different from this image. As we can see, it's now generating the image slowly but steadily. Let's visualize the generated image once it has completed this process. Now that the image is generated, let's visualize the image that's just generated. We can see that it's now a different image of a different person, but still it follows the prompt that we have given, which is the image of a model in London Bridge. That's precisely the prompt that we gave. We asked it to generate a cute model on London Bridge photo shoot. So that looks pretty much like a model on London Bridge in a photo shoot. So with that, I'm pretty much done with this. I hope the script is useful for you to generate images locally and also on Google Colab. I will share the link for this Colab notebook in the description of the video, and I will see you in my next one. Until then, take care.